So welcome to 4Keys A-Level Physics Instant Calculations. We have a question here under circular motion that we'd like to attempt. A horizontal flat plate is free to rotate about a vertical axis through its center as shown in Fig 1.2. So I hope you can see this diagram. A small mass M is placed on the plate. So here's the small mass. A distance D from the axis of rotation or from the center here. The speed of rotation of the plate is gradually increased from 0 until the mass is seen to slide off the plate. The maximum frictional force between the plate and the mass is given by the expression F is equal to 0.72 W, where W is the weight of the mass M. The distance D is 35 centimeters. Determine the maximum number of revolutions of the plate per minute. Number of revolutions of the plate per minute for the mass M to remain on the plate. So we need to dissect this question. The question even says here, explain your working. Explain your working. So it's not just about calculations, it's also about understanding what's happening and being able to explain. Okay, so let's see here. For this mass to remain here as the plate rotates, there has to be a frictional force that causes it to stay there. And when this frictional force can no longer hold this mass in place, this is where it's seen to slide off. So here we are being told that the maximum frictional force that is experienced by that mass is 0.72 of its weight. And its weight, we know that it's a force. It can also be expressed in terms of mass and acceleration. F is equal to ma, where our acceleration in this case would be equal to our acceleration due to gravity. So F is equal to mg. So we can change our W here to mg. So 0.72 of mg. That should be equal to our centripetal force. Okay, so we're going to create an equation. For as long as those two balance out, then that mass will remain in place. For as long as the friction is smaller, then it's going to slide off. So we are concerned with the maximum friction that is experienced by that mass. So let's do the calculations together. Okay, so we are going to start off here by saying 0.72 of the weight should be equal to your centripetal force. Okay, and your centripetal force is simply your mass times acceleration, but the acceleration here is centripetal acceleration. So what equations do we have for centripetal acceleration? So centripetal acceleration can be expressed in terms of velocity, v squared over r. In this case, our r is d, which is the distance from the axis of rotation to the point where the mass is. Or alternatively, we can say centripetal acceleration is equal to our r times angular velocity squared. Our r is d in the diagram times angular velocity squared. So we should go for this one. The reason is because we want this term here, angular velocity. Angular velocity would be our radians per second, and we can turn these to revolutions per minute. So let's see if we can figure out our angular velocity. So let's create the equation that involves here angular velocity. Okay, so I'm going to substitute d and angular velocity squared in this expression here. Okay, so d angular velocity squared. So with this, I can also express my weight here in terms of mass, where we say 0.72 of mg is equal to m. So these terms can go here. So So I have 0.72 of G being equal to my the distance there from the center, angular velocity squared. I have this, it's my 9.81 for G, and I have this distance. How many centimeters was that? 35, which is 0.35 meters. So I can find this. So this is where we are going with this. So at the end of the day, I have this expression here. So I have my 0.72 mg being equal to my m. I have 0.35 here, so I'm going to put the numbers. Angular velocity squared. Okay, so remember we said the masses can go. So if I substitute here my G, 0.72 of 9.81 should be equal to my 0.35 angular velocity squared. So divided by 0.35, and I root that. Okay, so if you simplify that expression that we just created, you're going to find your angular velocity as 4.49. So try to simplify that. It's in radians per second. Okay, so if we have our radians per second, we can turn these to revolutions per minute. You should remember that we have a relationship here. 1 revolution is equal to 360 degrees, and 360 degrees are equal to 2 pi radians. So what we can do here is we can divide this 4.49 by 2 pi in order for us to get our revolutions per second. So if I divide here by 2 pi, I change this into revolutions per second. And if I want to turn revolutions per second here into revolutions per minute, then I have to multiply this by 60. So okay, let's see here. So what I simply have to do here is to change here. I simply have to say that by 60. So this is the expression that would give me revolutions per minute. And if you simplify that expression, you get 43 revolutions per minute. So I hope it makes sense for you. You can always join our groups for further discussions. You can always contact me directly so that you get further explanations. So see you in our groups. See you in the next video.